Mercury, smallest and innermost planet of our solar system. It is slightly larger than our own moon. It makes a complete revolution around the sun in just 88 days. It has a wide variety in temperature. As it is closest to the sun, yet it is not the hottest. Its day temperature records 430 degrees Celsius, while at night it drops to minus 180 degrees Celsius. Sunlight takes just 3.2 minutes to reach Mercury. Surface of Mercury is just like our moon. It is full of craters. Mercury does not have an atmosphere. It contains only an exosphere, which is the extreme thin outer layer of the atmosphere. And the exosphere is made of atoms, which are blasted off the surface due to the solar wind and meteor strikes. Venus, the second member and the hottest planet of our solar system. Temperature of its surface is about 465 degrees Celsius. It is hot enough to melt even lead. Venus is the brightest object in our own sky after the sunset and before the sunrise. But we can't actually see the surface of the Venus because it is covered with thick clouds, so thick that it would even crush you. The atmosphere of Venus is made of mainly carbon dioxide gas, and thick clouds of sulfuric acid is there too. So while it rains, it's a sulfuric acid rain in the upper atmosphere only. And due to the extremely high temperature, the rain evaporates around 25 kilometers above the surface. The Earth, our home. We are fortunate here to have a never-ending cycle of the renewable resource, water. Evaporation from oceans, lakes, fields, etc. condenses and returns to Earth as precipitation, replenishing our reservoirs, our rivers, etc. Amount of this precipitation may vary from less than 0.1 inch per year in some deserts and more than 900 inches per day in the tropics. And this precipitation makes us alive, gives us the moisture required by plants and animals. The fourth member of our solar system is a namesake of the ancient Roman god Mars. It would take more than 6 Mars to fill up the volume of the Earth. It is believed that once this red planet had significant atmosphere to retain enough heat for liquid water. But over billions of years, it has lost it significantly. Now, with an atmosphere with 96% of carbon dioxide, it's a frozen desert with average temperature minus 63 degrees Celsius. When Mars was formed before 4.5 billion years ago, it had a much more substantial atmosphere with a higher pressure. This high pressure made the raindrops smaller and hard to fall. Rain on Mars would have been like fog rather than rain. As the atmospheric pressure decreases, raindrops got bigger and rainfall becomes heavy to curve into the soil, creating valleys. Have you ever imagined of rain of diamonds falling from sky other than water? Then Jupiter and Saturn are the answers. In both the planets, millions of tons of diamonds fall as rain. These planets contain abundant methane gas on their surface, and due to the frequent thunderstorms in their skies, these methane breaks into its primary components, which is hydrogen and carbon. Carbon falls through precipitation, and as it falls, its pressure increases gradually with an increase in velocity. Sometimes the velocity may reach up to 100 miles per hour. This leads to the formation of flat crystalline carbon atoms, This is graphite, what we use in our pencils. But as the temperature increases, these diamonds cannot stay in their solid state and they transform into liquid and are well preserved in the planet's cores. According to the scientists, 1000 tons of diamonds are formed each year, which can fill up 30,000 km deep land. The coldest planet of our solar system was discovered first with aid of a telescope in 1781 by William Herschel. It has abundant amount of hydrogen and helium in its atmosphere, and it rotates in the opposite direction compared to the most of the planets of our solar system. This ice giant does not have a true surface and it is mostly spinning fluids. The presence of methane gives it the amazing light blue color. Temperature of its outer atmosphere is minus 224.2 degrees Celsius. But as you approach the core, the immense pressure causes the temperature to rise up to thousands of degrees. And the temperature and pressure is so extreme that it would destroy even metal spacecrafts. But this could cause hydrogen and carbon to form diamond rain, some 8,000 kilometers below the surface. Diamonds that are millions of carats. Like Uranus, Neptune is also called the ice giant because the outer layer contains hydrogen and helium. In astronomy, ice means all the components of light elements that contain hydrogen. So the planet's water, ammonia and methane make them icy. Space missions to these outermost planets is extremely difficult. Only a single Voyager 2 mission revealed some of their secrets. Laboratory simulations for 40 years suggest about the diamond ring in Neptune 2. This tells us about the complexities of chemical processes in the internal nature of the world, which is far beyond the solar system. Those worlds that we may never see directly from the outside.